Let's define and discuss rational exponents. Rational exponents are another way to express radicals. For the natural number n and the real number a, the nth root of a can also be expressed as a to the 1 over n power. We have to be careful about the sign of a when the index n is even. If the radicand is non-negative, then the index can be either even or odd. However, if the radicand is negative, then the index must be odd for the radical to be defined. By definition, the nth root is the 1 over n power. Let's convert radicals to exponential form. The square root of 7 equals 7 to the 1/2 power. Similarly, the cube root can be written as the 1/3 power. The fifth root is the 1/5 power, and since 5 is odd, we can have a negative radicand. The fourth root can be written as the 1/4 power, but we need a non-negative radicand for the fourth root to be defined. Notice that 25x squared is greater than or equal to 0 for any value of x. Using the same principle, we can convert expressions with fractional exponents to radicals. 9 to the 1/2 power is the square root of 9, which equals 3. Similarly, -8 to the 1/3 power is the cube root of -8, which equals -2. 25x squared raised to the 1/2 power equals the square root of 25x squared, which equals absolute value of 5x. We need the absolute value here since the quantity x can be either positive or negative. Finally, the 1/7 power means the 7th root. So far, our rational exponents have all had the form 1 over n. We can generalize our definition to include all rational exponents. Suppose that m and n are natural numbers and that a is any real number. Then a raised to the m over n power means the mth power of the nth root of a. We still need to guarantee that even-indexed radicals have non-negative radicands. Notice that in the fractional exponents, the denominator indicates the index and the numerator indicates a power. Let's consider two quick examples. 9 raised to the 5/2 power equals the 5th power of the square root of 9. Thus we have 3 to the 5th, which equals 243. 27 raised to the 2/3 power equals the square of the cube root of 27. Thus we have 3 squared, which equals 9. Let's quickly review some basic properties of exponents. When we multiply like bases, we add the exponents. When we divide like bases, we subtract the exponents. When we raise a power to another power, we multiply exponents. And a negative exponent means to reciprocate. Importantly, these laws hold regardless of the type of exponents. So we can use the laws of exponents to simplify expressions involving fractional exponents. Let's consider 3 examples. To compute a to the 1/2 times a to the -2/3, we add the exponents. To add fractions, we need common denominators. 3/6 minus 4/6 equals a negative 1/6, so we have a negative exponent. Simplifying exponential expressions typically includes elimination of any negative exponents, so we get the reciprocal of a to the 1/6 power. Now let's consider a product to the negative 1/2 power. There are several ways we could proceed here. Let's start by using the property that says we can apply the power to each factor. We again have several options. 6 to the negative 1/2 power is 1 over the square root of 6. The square root of x squared is absolute value x, but we still have an exponent of negative 1. And negative 4 times negative 1/2 gives me a power of 2 on my y factor. Finally, we want to take care of the negative 1 exponent by reciprocating. Let's finish with a simpler example to illustrate how we might choose to proceed by taking care of the negative exponent first. A negative exponent means to reciprocate. Now the 1/2 power applies to the numerator and to the denominator. And the 1/2 power is the square root. So we have the square root of 25 over the square root of 9, giving us a final answer of 5/3. It takes some practice with homework problems to gain the experience necessary to make decisions about proceeding efficiently, so don't be hesitant to rework problems in multiple ways.